Here is another practice problem on operational amplifier for gate. So we have to find out the output voltage assuming that both these op amps are ideal in nature. So with a problem like this, I have been repeatedly stressing in my previous videos that we have to spot any voltage divider, and voltage dividers take a shape like so, where you have two resistances R1 and R2 which are connected in series, and they are supplied by some voltage of Vp volts. And if we want to find out the voltage at this node, so this is the voltage drop across this resistance R2, and it is very handy to remember this equation as R2 by R1 plus R2 multiplied by Vp. And so looking into this circuit, we we can see that right over here is one voltage divider. And so the supply here is 5 volt, and you have two resistances. So R1 is equal to 20 kilo and R2 is equal to 10 kilo. And therefore we can easily find out the voltage at this node to be equal to 10 divided by 20 plus 10 multiplied by 5 volts. And therefore we can note this voltage to be equal to Vp, and this turns out to be 5 by 3 volts. Next, we apply the concept of virtual short, and we note that the voltage at this node must be the same as the voltage at the other node, and therefore we simply note this voltage to be equal to 5 by 3 volts. So moving forward, we found out this voltage to be 5 by 3 volt, and therefore the voltage at this node is 5 by 3 volt. And then we can also remember that with an ideal op amp, it draws no current into its input terminal. So if some current I1 flows from this 1 volt source, then it takes this 10 kilo ohm branch, and therefore we can frame the expression as I1 is equal to I2. Proceeding forward, we can mention I1 as 1 volt minus of 5 by 3 volt divided by 20 kilo ohm, and we can equate it to I2. So I2 is equal to 5 by 3 volt minus of voltage at this node. So this node voltage is unknown, and we can note it as V sub n. So 5 by 3 volt minus of V sub n divided by 10 kilo ohms. And so this is that equation from where we find that Vn is the only unknown, and we do this little math and Vn turns out to be 2 volts. So the voltage at this node is equal to 2 volt. Next, we look at this particular node, and then we can once again claim that if this is the current I3 and the outgoing current is I4, then I3 should be equal to I4, because once again this operational amplifier is blocking any current flow through its input terminal. And therefore, if I3 is equal to I4, we can frame another set of equation as Vn minus of voltage at this node. So the voltage at this node is the same as the voltage at the other node because of virtual short, and therefore this is at 0 volt. So I3 can be framed as Vn minus of 0 divided by 40 kilo ohms, and I4 can be framed as 0 minus V0 divided by 100 kilo ohms. So this is that expression from where we find that V0 turns out to be minus of 100 by 40 times Vn, and then again Vn is equal to 2 volts. Therefore V0 is equal to negative 2.5 times 2, which is equal to minus of 5 volts.